Continuous delivery is state-of-the-art for software development. It's how the best teams and organisations structure their work. But what is it really, and how do we tell if we're succeeding at continuous delivery? Fundamentally, continuous delivery is about working so that our software is always in a releasable state. But how can we tell if we're doing that? What are the real markers for continuous delivery? I think that there's either one or perhaps a bit more helpfully 14 things that are clear signs of continuous delivery. So here are my 14 markers for continuous delivery. Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content today, please hit like as well. My perspective on this was inspired by the work of Brian Finster and his friends, who pulled together the definition for minimum viable continuous delivery. I like the minimum CD stuff a lot. This isn't an alternative, but is rather complementary, to my mind at least. But being completely minimalistic, the one real metric for continuous delivery, the real minimum of minimum viable CD if you like, is that if you can determine the releasability of your software on at least a daily basis, then you're practicing continuous delivery. Doesn't matter if you're using all of the cool continuous delivery tools or not. Doesn't matter if you bought mine and Jez's book or not. Doesn't matter if you actually release into production every day or not. Doesn't matter if you have a certificate from one of my very good training courses or not. If you can determine releasability at least once per day, it's continuous delivery. And if you can't, it's not. I like that it's that specific. Not much room for nuance here, really. The only caveat that I'd add is that there's no real wiggle room here either for what releasable means. By releasable, I mean that there's no more work left to do other than initiate deployment into production. No more testing with other things before release, no more approvals, no more documentation left to do. No more compliance hurdles. It really is ready to go. I do like the clarity and simplicity of this definition for continuous delivery, and I think it is profoundly true. And also not necessarily obvious, so not really how many people think of CD or structure their work. So I think this is a useful and important idea to point out. But at this stage, even if people are happy with this and understand it as a good definition, how can we use this to determine what steps to take to get us from where we are today to the target of where we'd like to be, great software development, delivering better software faster based on continuous delivery? Well, the 14 markers are meant as tools to help us steer our activities a little more precisely toward this goal. Mostly sub-goals that, if you reach them, will mean that you are now practicing continuous delivery. And if you are practicing some of them, you're closer to it than you were before. The first of the 14 is the restatement of the general goal, continuous delivery. We have the capability to release changes into production at least once per day. As I've already said, I like the clarity and simplicity of this statement. But I'm also a pragmatist, so I also feel slightly wary of seeming to be too dogmatic. I don't really believe in rules as much as guidelines, but guidelines usually come with consequences. I think that you need to be able to determine releasability at least daily. Otherwise, what on earth does continuous mean in this context? The idea here is continuous is not literally continuous, but it is intended as a guide to steer us to prioritize keeping the software in a releasable state above everything else. Are there special circumstances then, corner cases maybe, in which we can sensibly relax this rule to allow more work on outside of that day? Once releasability is determined, yeah, I think that there probably are. If you can determine the releasability of a change within the working day, but for some reason there's a mechanical process that takes a long time as part of the production, maybe burning silicon, for example, then if this process is genuinely mechanical and predictable enough to almost never break things, then yeah, I think that would still qualify. But the consequence is that if it does break things, you won't have very clear visibility of the failure or timely feedback into the development process so that you can correct it quickly and efficiently. And so this failure is now unlikely, but is also going to be more problematic if it does happen. It's a typical engineering style trade-off here, really. The real point here is that the goal of daily releasability is the right goal to aim for. If you aim for this, but can't quite, for some extremely unusual physical constraining reason, achieve it, you will still be in the best possible position as a result of striving to come asymptotically close to it. And no, you can't use that as a get out of jail free card just because your build is too big and too slow or your tests are too poorly written to give you results fast enough. Striving to improve these things is part of the reason why continuous delivery works better. Because in striving for more efficient, better quality builds and tests, it helps you to fix other, maybe more important things too. You can always optimize these things to run fast enough, and you should if you pay attention closely. If you'd like to learn more about all of these practices, I have a training course, Better Software Faster, that will take you through all of the ways of working, the principles behind them, and the benefits that you and your business will gain from practicing continuous delivery. There's a link in the description to that course below. Second in my list is the deployment pipeline. We have a deployment pipeline that includes all steps and tests that are sufficient to determine releasability for our systems. The minimum CD site mirrors this very nicely. So when a change has completed its transit through the pipeline, there's no more work to do for the software to be released into production. The deployment pipeline is the mechanism through which we determine releasability. It's definitive for release and is the only route to production, whatever the nature of the change. The pipeline starts with continuous integration, triggering an evaluation of changes after every small commit. Artifacts created by the pipeline always meet the organization's definition of deployable if the pipeline says that they're good to go. Third in my list of markers, continuous integration then, we can safely commit small changes multiple times per day while keeping the system working. CI is a foundation of continuous delivery. It's not really possible to practice continuous delivery in the absence of continuous integration. It doesn't make any sense. I sometimes get a bit irritable by people calling it CI/CD as a result of that. CI is more important and seemingly a trickier idea than many people think. The ideas that are at the heart of CI are really about controlling the variables by working in smaller steps and being definitive about what represents our current understanding of the system. My favourite quote from the C2 wiki that first popularised the idea of continuous integration is, continuous integration is based on the idea that there is only one interesting version of the system, the current one. Effectively, in CI, we take a snapshot, a still of the system and evaluate exactly that version in some detail. To put it another way, CI is a process where everyone evaluates their changes along with everyone else's changes at least once per day. Once per day isn't really enough, but most continuous integration and continuous delivery experts will grudgingly concede that daily will qualify, if only barely. Fourth in my list of markers, trunk-based development. We don't hide work on separate branches for longer than a working day before integrating them together. Trunk-based development is contentious, but it is realistically essential to the operation of continuous delivery because it's fundamentally essential to the operation of continuous integration. So technically, yes, you can still practice continuous integration, at least daily integration, with feature branches as long as the feature branches last for less than a day. But that's the only way in which continuous integration and feature branches are compatible. The common pushback that I often get on this topic is, yes, but I pull changes from trunk to my branch. That's the same thing. No, it isn't. Not at all. Because if everyone else on the team is also hiding their version of the code on their feature branch, then what you're pulling from trunk isn't interesting. It isn't the truth of the system. There's no sense of a current version here. until all of the features are supposedly finished. Because now the reality of the current version is that it only exists as a distributed, unintegrated, possibly incompatible collection of changes on different people's feature branches. And only finding out after you think you're finished that you've broken the world is not even close to continuous integration. CI is defined as integrating everyone's changes at least once per day, and you can't do that if feature branches last for more than a day. Next, small autonomous teams. We share responsibility for writing and testing code and deploying it into production. The predictors of success for software development teams are clear from the data. We need small teams and we need autonomous teams. Actually, I think that things may have improved in terms of team size over recent years. It's a while since I last met a team of 20, 50 or 100 people that refer to themselves as being one big team, without also breaking that team down into smaller sub-teams. This matters a lot because small teams of people are dramatically more efficient than large groups. On average, a team of 5 people produces higher quality software nearly 4 times faster per person than a team of 20. That is, over a 9-month period, they'll produce the same amount of software but with 5 times fewer defects. Autonomy, though, seems harder for people to achieve in practice. But it is essential to really achieving and sustaining the kind of flow that continuous delivery as a practice depends on. The reason why autonomy matters is that without it, the development process becomes highly coupled. And that is even worse than software being highly coupled very often. At least if the software is highly coupled, we can alleviate the pain of that with shared continuous integration. If the development process is coupled, project owners defining solutions instead of requirements, that don't work very well. UI UX teams defining exact UI layouts for every feature. Architects prescribing rules for design that don't really work in practice. Developers throwing untested code over the wall to testers and so delegating responsibility that in reality they should take ownership of. And so on and so on. I think that the very best that you can hope for with a process like this is kind of adequate or barely adequate software. And only that if you're fairly lucky. If you want to make good software or great software, you need teams with more responsibility, more ownership, more autonomy. This is not just my opinion or personal experience, it's also what the DORA research says. Next on the list, informed decision making. These autonomous teams have visibility and control of their processes and data, and are able then to make informed decisions without requiring permission or coordination from outside the team. When we talk about autonomy in teams, this is what we really mean, not some kind of abstract thing. The teams have the information that they need and the responsibility and ownership sufficient to act on what they learn as they make progress. This kind of autonomy is not easy to achieve, but it is what it takes to do good work. Next, small steps. We grow our code incrementally, making frequent small changes, leaving our code in a working state after each small change. Working in small steps at every level of software development is important. We want requirements to define small focused needs rather than vast vague projects. Adding a feature that takes a day or two to create and then checking that it is good is obviously more likely to be communicated effectively and to succeed than asking for some vast indistinct 6 months of poorly targeted work. And even if the 2 days' work is wrong, you've lost 2 days instead of 6 months. I've been fortunate to work with some very talented software developers during the course of my career, and for me, the standout feature that distinguishes the great ones from the average ones is that all of the great developers that I know work in small, even tiny steps, reconfirming where they are after each tiny step. Not all of them practice test-driven development, but one of the many benefits of test-driven development is that it encourages us to work in these smaller steps like this. Next, fast feedback. We get feedback on the quality of our work after every tiny change. Fast feedback matters profoundly and is intimately tied to the small steps that we adopt as the core to how we organise our work in continuous delivery. From a software engineering perspective, the feedback that we gain from working in these small steps provide us with more opportunities to learn. The data that we gather from that feedback is information that allows us to adapt to what it is that we've learned, and so make better informed choices about which step to take next. Next in the list, automated testing. We automate almost everything in our deployment pipeline and have enough automated testing in place to validate and release our changes without dependence on manual regression testing or on separate QA and approval processes. Automated testing is at the heart of continuous delivery. This is because this is the best way to deliver fast, clear, high-quality feedback into the development process. Test-driven development in particular gives us the fastest route to feedback on the quality of our design choices. If your code is hard to test, that's a signal that your design is poor. In the form of TDD, also known as BDD, it also gives probably the fastest, clearest feedback on the coherence and relevance of our product thinking. I've started describing development as a translation process from vague wish to the precision of working software, carried out as a series of small steps. Vague wish to use a story, story to example, example to executable specification, and executable specification via test-driven development to working software. If we can't think of user need in terms of a story, we don't understand what our software is meant to achieve yet. If we can't think of an example that would demonstrate that the need that story represents is fulfilled, we don't really understand the problem domain yet, let alone the need. You don't really get to build good software without understanding these things. So if you struggle at any stage in this process, it helps to focus your mind on the kind of questions that you need to ask to address these problems. Automated testing, as I prefer to practice it at least, is about an awful lot more than testing or automation. Next in the list, version control. We make all changes to code, test, infrastructure, configuration, and ultimately production via version control. Good version control is about a lot more than only source code control. For every release, we know which version of the infrastructure was used and which version of tests were run. There are types of software where the creators don't always own the environment in which the software operates. But the creators of the software should always exercise control to the limits of what's possible. And we can take possible a lot further than most people think. In reality, the applications that you create depend on whole stacks of software that other people wrote. This is always true. If any of those other pieces of software can break your software, you'll be doing yourself a very big favor if you limit the degree to which they can change outside of your control, and so break you outside of your control. If you own the environment that hosts your system, then adopt infrastructure as code techniques to version control the entire stack. I'd recommend that you don't abdicate that control lightly under any circumstances, and that you do whatever you can to insulate your system from changes to the stuff that is outside of your ability to control. Version control is by far the best way to exert this kind of control in practice. Next on the list, there's one route to production. All changes flow through the pipeline. What we evaluate in the pipeline is exactly what we release into production. Using the pipeline as the only route to production has lots of very useful benefits. It allows us to test all kinds of changes that are often otherwise not tested. Configuration changes, changes to the operating system, upgrades to the language, or infrastructure upgrades. Any change, in fact, to our production systems, really. This step allows us to upgrade these environmental dependencies of our applications more frequently, and just one benefit of that is that our software is more secure as a result. Estimates say that 95% of the attack surface area for security exploits is closed if none of our infrastructure is older than 8 months. Next in our list, traceability. Our deployment pipeline provides complete traceability of all steps in the software development process. For every change, we know the version of the infrastructure, who made what changes, which tests were run, which test data, and the results. as well as the details of the change itself. The huge win for traceability is primarily in regulated industries, but it does go beyond that. By ensuring that the pipeline represents the only route to production, it means that we are in the ideal position to record all change to production systems. So accurate audit trails are now trivially simple. Introspection and review of actions that led to problems is also much simpler than before. And all of this comes essentially for very negligible additional effort. If we want, we can achieve complete end-to-end traceability of change for very little additional effort. This comes as a side effect of the way that we're working really anyway. It's almost impossible to imagine being able to create a functioning deployment pipeline that doesn't also act as a complete, accurate, searchable space for everything that contributes to change in production. 13th in my list is automated deployment. We can deploy our changes into production or any test environment at the touch of a button. Our focus on automation in general, infrastructure as code and automated tests in particular, encourages us to automate the deployment of our systems too. This leads us almost as a side effect to great deployment flexibility. We also get to rehearse deployment, and so we can be more confident that by the time our release candidate reaches production, it's certainly going to deploy successfully because it already has several times as it transited the deployment pipeline. Last in my list, observability. We monitor indicators from production to determine the success of our changes. Given the levels of control and insight that we now depend on in continuous delivery, we can extend that into production too, and learn from the use of our products by real users. Is it fast enough? Is it reliable enough? Is it making money for the company or encouraging more users to adopt it? We can use techniques like site reliability engineering and define measurable outcomes for each change in the form of service level indicators and service level objectives. And so now we're really moving into the realm of being more experimental as we develop new products, a genuine incremental approach to software engineering. I think that these 14 markers of continuous delivery represent extremely useful guide rails, helping organizations to steer their path towards continuous delivery adoption. I plan to do more based on these principles, so do let me know what you think of them in the comments below. Thank you, and bye-bye.